Hi folks, now we're gonna change it up a little bit. The idea being is I want to show you some pretty pictures, if you will. This is sort of to remind you what this class is about before we get to talking about the scientific method. So here is a picture showing Pluto being demoted from a planet to a dwarf planet, but also the lineup of the other planets that we have here. So Mercury, Venus, Earth, and Mars, Jupiter, Saturn, Uranus, and Neptune. And this picture here is, for some of you, it's obvious it isn't. These planets are not placed in their proper orientation as far as distance away from the sun is concerned. But this picture does show the sizes and the orientation with respect to those that are closest to the sun to those that are furthest away. You can see that the sun is huge in comparison to the other ones. This is a picture of Jupiter from a ground-placed telescope, and this is a picture of a photograph of a planet going around Fomalhaut. So Fomalhaut is one of the brighter stars in the southern sky. We see it in the south, I mean. And here we have a picture of showing evidence of a planet going around another star. Okay. Now, I think we are on the order of have observed the effects of 3,400 planets going around other stars at this time. This number changes so frequently, it's like a cottage industry. Every day a few more get observed. So planets, now normally the way we observe planets is by the effect that they have on the star. Sometimes they get in front of it, so the stellar output that we observe decreases by a little amount. Or we also observe them because just like when you were sitting on a teeter-totter with your parents, they would move because of your actions. And so we see the star move because of the actions of the planet. So that's how we observe these things. Now this is showing some planets, if you will. There's one right there, and there's another one up here, and I'm uncertain if we can see any other ones in this picture. This is a picture I took of, of the moon and Venus right in front of Guitar Lake quite some time ago. But the point I wanted to get across here is, life is a participation sport. And hopefully what I'm going to be talking to you about is the participatory nature of our understanding about the world. People go out and try to figure these things out, and they participate in life. And you can be part of this journey. Here's some pictures of planets and the moon over Los Angeles. The rings and moons of Saturn. A nice picture that the Voyager took. The sun is behind the planet here, and so that's why we get to see all these outlines of the rings. This is Titan, a picture looking down like a bird's eye view, very bird's eye view. And then this is what one of our spacecraft, the Huygens lander, when it landed on Titan, saw. Titan is a possibility there's possibility of life there. It would be very different than our own. So is this a beach in Santa Monica? From my connotation, enunciation, you probably know that it isn't. This is a picture taken on Mars. But look at the sand here. If you didn't know any better, it could be Santa Monica. Of course, at Santa Monica up here, you would have, the Ferris wheel and things like that. Another pretty picture. This is an interesting photo showing that was taken in the same location. Let's see, probably once every week. There were probably 52 of these suns here. And the idea is that this was taken at the same time every day. And you see how the sun moves in response to the seasons. So this is actual seasonal motion of the sun in the daytime sky. Okay, it moves up and down and backwards and forwards relative to the meridian of your location. Now, mind you, a lot of these words you don't know yet, but you will during the course of the semester. The supernova remnant, as I said before, we probably won't get to talk a lot about it, but maybe we'll touch upon it in the last lectures or so. And the sun we will be talking about in detail. You can go to the SOHO website. SOHO is an observatory associated with NASA, and all this information is available to you. It's free to look at. Another picture of a wonderful picture of galaxy. If you take the other astronomy class, Stars and Galaxies, you'll learn more about why it looks like the way it does and why the colors of the light here are so blue and why we have it's so basically golden down in here. Another one, and a M40, which is a globular cluster, about as old as the universe itself. And another beautiful nebula, a stellar nursery. And this one is of Orion, and something you probably ought to take a look at if you ever get to a star party. Helix Nebula, I haven't seen this one yet, and this is a star being born. So we won't get to talk about that in this class, but you will in the Stars and Galaxies class. Another pretty picture. Another pretty picture. Seen that guy. This is like one of the best pictures all around. Deep field from Hubble. And if you look at this photograph here, there are only a few pictures of stars in our galaxy in it. You can tell it by the artifact. See the star, the cross-shaped effect? That's an artifact associated with the lens of Hubble. It shows up here. But the rest of the little bits of light here, these are galaxies. And this is the amount of sky that we're seeing here is like a grain of sand held at arm's length. It is really small, so no matter where you look, you're going to see galaxies like this just all over the place. So let's see, we can, well, there's one star there, and I guess I'm having difficulty finding, well, there's another one there, and I'll let you pause or wander around, find these things. Okay, so bunch of pretty pictures.